Hi friends, this is lecture number 15. This is very important topic. Today we are just talking about the spanning tree. So what is the spanning tree? My suggestion to everyone that before coming in this lecture you must also complete the lecture number 13. That is very important. We have covered everything in the lecture number 13. So now here spanning tree. A spanning tree is a subset of graph G which has all the vertices covered with minimum possible number of edges. Okay, hence a spanning tree does not have cycles and it cannot be disconnected. Okay, so what is he is writing? You can see that there are total number of 3 nodes that are connected. Already they have written a spanning tree is a subset of a graph G which has all the vertices covered with minimum possible, means at first you have graph, then after then you are finding how many ways you can write the same form but it not be connected. So you can see that the first one we have written this is A, this is B, this is C, and after then we have written this is A, this is B, this is C, A, B, C. At first we remove this edge, okay, we remove this edge, and after then we remove this edge, okay, after then we remove this edge. Okay, so there are only 3 possibilities to write this graph to this form. Okay, so he has written a spanning tree is a subset. This is the also these are all the subset of graph G of this which has all the vertices covered. All the vertices we have covered. Okay, you can see that we have not removed any node. Okay, we have covered with minimum possible number of edges. You can see that minimum number of possible means we have removed only one. Okay, here also we have removed only one. Here also we have removed only one. Minimum possible number of edges. Hence the spanning tree does not have cycles. Now you can see that there is no cycle. Okay, there is no cycle and there is also no cycle. And it cannot be disconnected. What is the meaning of connected? It not be connected means it not be disconnected means it not be connected. So you have to remove this one, you have to remove this one, you have to remove this one. So there are 3 possibilities only. So there are total number of 3 spanning tree can possible. What we have written, every connected or undirected graph. What is the meaning of undirected? Okay, if I am writing this node like this form, okay, so this is the directed graph. If I am not writing any symbol just like this, then this is the undirected graph. Every connected, this is the connected, and undirected, there should be no direction. Okay, if there is a direction, then this is the directed graph. If there is no direction, then this is the undirected graph. Every connected, this is the connected, and this is also undirected graph has at least one spanning tree. Okay, he has written, this is the statement, has at least one spanning tree. A disconnected graph do not have a spanning tree. Okay, so this is the statement by the help of this conclusion. Okay, so now there is a question. Question is, if suppose you have many nodes, okay, this you have such a, how many nodes, how many spanning tree can possible? How many spanning tree can possible? I am just giving you one example. This is the formula, you must learn it, n to the power n minus 2. If you have such type of any question has given in your exam, in your GATE exam, suppose you are preparing GATE or any exam, and he has asked how many spanning tree can possible. It must be not means your node it not be not cut. Okay, suppose you have this form. Okay, you will not use this formula for such type of graph. Okay, you have to use for the only for this graph. It means your edge it not be intersect. Okay, so only for this formula it will be applicable only for such type of form. Suppose you have this form. Okay, this okay, in this condition, or suppose you have any this such type of form. Okay, in this condition you will use n to the power n minus 2. So here total number of nodes are 3 to the power 3 minus 2, and 3 to the power 3 minus 2 is equal to 1. 3 to the power 1 is equal to 3. Now you can see that only there are 3 possibilities. Now the one question it has come in your exam, he has asked, you have this, now this time he has given you this, how many spanning tree can possible? He has asked how many spanning tree can possible. He has asked. Okay, so he has asked how many spanning tree can possible. So this question he has asked in your exam, okay, in your GATE exam especially. I am also using this, okay. Now he is asking how many spanning tree can possible for this question he has asked. For such type of question, you know that there is a all the edges are you know that they have intersect, okay. In this condition it is very hard to find, okay. So in this condition I am using one formula. You have to use this formula, and the formula is at first you have to use nothing. Suppose this is how many, this 1 2 3 4 5, total number of nodes are 5. So so here you have if you that its name is dense graph, okay, actually, okay. This is not the dense graph. It is not intersect. So this is a simple graph. For simple graph you will use this formula, n to the power n minus 2, total number of spanning tree. If this is actually dense graph, okay, so this is dense graph, have a lot of edges. You can see that there are a lot of edges compared to the number of vertices. You can see that there are total number of vertices are less, but edges are more, okay. So vertices there can be at most n into n minus 1 upon 2, okay. So there can be at most, this is the maximum number of edges, okay. Every node is connected to any other nodes, that is n into n minus 1. So total number of edges these are connected to other nodes it is n into n minus 1. So in this condition we have to find that how many spanning tree can possible. So you have to note the first one is how many edges can possible here. So total edges is equal to n into n minus 1, okay. How many nodes? 1 2 3 4 5. So 5 into 5 minus 1, 5 4 ja 20. So there are total number of 20 edges. Now you can count how many edges are here, you can count. So now after then we have to find that now you can after then we will write, but here we have to count the edges only one time, so n into n minus 1 upon 2, okay. So this value it will be n into n minus 1 upon 2. So this is 20 upon 2 is equal to 10. So total number of 10 spanning tree can possible. Now how? Now you can see that here you can see that we just remove this one, then we remove this one, then we remove this one. Similarly for this, at first we will remove this, then this, then this, then this, then this. Total number of 5 plus, okay. Then and the second condition, what we will do? Okay, then we will remove this, then we will remove this, then we will remove this, this, okay. So total number of 5 possibilities. 5 plus 5 is equal to 10. The total number of 10 possibilities are there, okay. So now I will give you some statement of spanning tree. I am just erasing it and I will write some statement about the spanning tree, okay. I am erasing it. That is the sufficient questions for the spanning tree, okay. So these is some topics. These are very important if you are writing about just thinking about the spanning tree. Actually last time I just before 1 minute I show you one example. Maybe there some questions arising in your memory for spanning tree, because already we have not written the depth definition of the spanning tree. Here we have written all the concept. The first one, connected graph G can have more than one spanning tree, okay. You can see that, okay. All possible spanning tree of graph G have same number of edges and vertices. Now you can see that here also same number of edges and vertices. How many spanning tree you are constructing, okay. So every spanning tree must have same number of edges and same number of vertices. So maybe in the previous question, maybe there are some questions in your memory, maybe, but you must think here. We have to follow this condition. Okay, all possible spanning tree of graph G have same number of edges and vertices. This is very important. The third one, spanning tree does not have any cycle. You can see that there is no cycle. Removing one edge from the spanning tree, then after that you will say that this is a graph. This is graph, everyone is a graph. If you will add one edge in a spanning tree, then after that it will become loop. If you will connect something, then after that this is the loop. Okay. So now a spanning tree has n-1 edge. Okay, this is also another important topic for you. Maybe in just before 1 minute, 2 minutes, there are some questions in your memory for that question. Okay, spanning tree, why are you writing only 10 spanning tree can possible? Because there are some restrictions. The spanning tree has n-1 edges, and this spanning tree have same number of edges and vertices. Now the last one, from complete graph by removing maximum E means edges, minus n+1 edges, we can construct a spanning tree by the help of complete graph. Okay, we have also created many lectures for graph. What is the complete graph? You must to go there. So now here we are just talking about the spanning tree, and the last topic I will say, spanning tree are the subset of connected graph G. This is the connected graph G. Okay, the spanning tree, that is the subset. These are all the subset of connected graph G. So that is the definition of a spanning tree, and all the questions, gate questions, and all topics, everything we have covered. If you are facing any problem, then you must write in your comment box, and we will try to just remove your if you have just query, then after that we will try to remove your misunderstanding on this topic. Okay, thank you so much.